Hi everybody. Today I am going to teach you how to find the equation of the least squares regression line. And I'm going to teach you 3 different ways to do it. And I mentioned yesterday in class that the method that you choose is just going to depend on what information you're given. Okay, it's going to be obvious which method to use based on what you have. First, I need to give you some reminders about correlation because it's been a few days since we talked about it. Correlation measures the strength as well as the direction of the linear relationship between 2 quantitative variables. The strength is measured by how close the value of the correlation is to 1 or -1. The closer it is to 1, the stronger it is. The closer it is to -1, the stronger it is. The direction is indicated by whether it's positive or negative. So positive correlation means that my scatter plot would show a positive slope. Negative correlation means that my scatter plot would show a negative slope. And our abbreviation for correlation is the letter R. As I just mentioned, R falls between -1 and 1. Data with a correlation of exactly -1 would be a perfect negatively sloped line. Data with a correlation of +1 would have a perfect line with a positive slope. And what would a correlation of 0 look like? It looks like a mess, a random scatter of points. It looks like a beehive that I kicked and the bees went and flew around everywhere, okay? As I said, a positive correlation means that the linear relationship has a positive slope, and a negative correlation indicates a negative slope. And the closer our correlation gets to 1 or -1, the closer to a straight line our points are on. To be clear, correlation doesn't tell us what the slope actually is. It just tells us how strongly linear it is and if it's positive or negative. So correlation and slope are not the same thing, obviously, because slope can be much larger than 1 or much lower than -1. They're not the same thing, they just match, okay? And correlation tells us how strong that relationship actually is. Do not write this down. It's in your reference sheets and you will never use it. This is the actual formula for correlation. And if you notice, what does this guy look like? I have individual x values minus x bar over the standard deviation in the x direction. This is a z-score. And this is also a z-score. This is a z-score for the x-coordinate of one of my points. This is the z-score for the y-coordinate of that point. So basically, I'm averaging together the product of the z-scores in the x direction with the z-scores in the y direction. Okay? Again, you do not need to know this, but I do want you to see where this comes from. Correlation and z-scores are very closely connected. Okay, so as promised, you're going to learn 3 different ways to determine the equation of the least squares regression line. The first is using data, and if you're given data, you can do this in the calculator. The second is using summary statistics. I'll explain what that means when we get to it. And the third is using a computer output. For the calculator, okay, the first thing we need to do is to turn the diagnostic on in our calculator. I don't know why it's not automatically on. Nobody in the statistics world that I've talked to knows why this is the case. If you know somebody who works for Texas Instruments, feel free to ask them. But I'm going to lead you through how to do that. Once you do that, it's done, okay? So let's just skip straight to the calculator. I'm hoping you still have the manatee data in your calculator from yesterday, okay? Take a look. If you do, your list 1 and list 2 should look something like this. 447, 460, 481 in list 1, and 13, 21, 24 in list 2. I want you guys to take a look around and see if there's anybody that needs this data. If you do, I'll pull it back up and pause the video so that you can do that. If not, skip past this part. If you remember with this data, we eliminated year and we only cared about powerboat registrations and manatees killed. So remember, all the powerboat registration numbers went in list 1. All the manatees killed numbers, went in list 2. So if you need to enter this data, please pause. Okay, now that we have our data in our calculator, I'm scared, so I'm going to quit. Back to my home screen. And as I mentioned, the first thing that you need to do is to turn your diagnostic on. To do this, you're going to hit second, 0. This takes you to your calculator's catalog. This has a list of every command that's in your calculator. And if you notice in the top right corner, it shows that your alpha key is already on, which means if you type one of your lettered keys, it'll jump you down to that part of the catalog. We're looking for diagnostic on, so hit the button that has D above it. It's the X to the -1 button. Everybody should be helping their neighbors if you get it and your neighbor doesn't. So that jumped you down to the D's, and you're going to scroll down, 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 down until you get to diagnostic on. Oops, I skipped right past it. Darn it. All right, hopefully you're finding this faster than I am. Oh, sorry, this is incredibly awkward. There we go, diagnostic on. When you're there, hit enter, and it'll take you back to your home screen, and hit enter again, and it's going to say done. So everybody's home screen should show diagnostic on, done. Help your neighbors if they need help with this. Now that you've done this, it's done. Okay, kind of like how when we turn stats wizards off. All right. Now, to find the equation of the least squares regression line, you're going to go to stat. We're performing a statistical calculation, so you're going to toggle over to the calc menu. And this is not one variable stats. This is not really two variable stats. We're trying to perform a linear regression. Now you may see option 4 here, linreg ax plus b, but that is not the one we want because we do not use the ax plus b form of the equation. We use a plus bx. So you're going to scroll way down to option 8, which says linreg a plus bx. That's the one you want to choose. Linreg a plus bx. If you hit enter again, it should give you 4 things. Actually 5 things. First, it's going to remind you y is equal to a plus bx. It's going to tell you what a is, and it's going to tell you what b is. It's going to tell you what r squared is, but we haven't learned that yet. But look at this. It also gives you r, the correlation. So not only have I found the equation of the least squares regression line, but I've also found the correlation. Okay? By the way, if I want to take this equation and add it over top of my scatter plot, I can do that. So we know that y hat is going to equal negative 41.43 plus 0.125x. That's how I would read that. If you want to add that least squares regression line over top of your scatter plot, you can do that. You just go to your y equals, not second y equals, but your regular y equals, and type it in. So negative 41.43 plus 0.125 x, and this button right here next to the alpha is where you get your x. Okay? Then I'm going to make sure that I still have my scatter plot in there. So second y equals, I do, plot 1 is on, and it's a scatter plot of list 1 and list 2. So I'm scared, so I quit, and I zoom 9. And there's my scatter plot with the regression line drawn over top of it. And I can see that that's really a very nice fit. Okay, so for the manatee problem, okay, we made a scatter plot of the data already. we found the equation of the least squares regression line, and we determined the correlation. What I want you to do now is from video 4, I want you to interpret the slope and y-intercept of this equation in the context of the problem. And I want you to predict the number of manatees that will be killed by boats in a year when 716,000 power boats are registered. All right, so make sure that everybody's got the scatter plot and the equation of the least squares regression line. And then I want you to interpret the slope and intercept and make that prediction. Pause the video now, please. Okay, so the equation of my least squares regression line was y hat is equal to negative 41.43, plus 0.125x. And let's go ahead and define our variables. X was the number of power boats registered in thousands. That's how that was measured, was in thousands. And y hat is the predicted number of manatees killed. Okay. To interpret the slope, remember, as x increases by 1, we predict y to increase or decrease by the slope. Here is my slope, 0.125. So as x, the number of registered boats, increases by not 1, but 1,000, because that's how x was measured, we predict the number of manatees killed to increase by 0.125 on average. Don't forget that on average. Now I know we cannot have 0.125 of a manatee, okay? But that's okay. We're talking about an overall trend. As the number of registered powerboats increases by 1,000, we predict the number of manatees killed to increase by 0.125 on average. Okay. For the y-intercept, I'm going to do it up here because I don't have any room. Remember, the y-intercept is when x is equal to 0, we predict y to be the y-intercept. In a year with 0 registered boats, we predict how many? Negative 41.43 manatees killed. Does that make any sense? Of course not. This does not mean that if there are no boats registered that manatees will start appearing out of thin air. Okay, that doesn't make any sense. This would be extrapolation. In my data, I didn't go anywhere close to 0 registered boats. So this makes no sense. We don't like it. Okay, to predict the number of manatees that will be killed by boats in a year when 716,000 powerboats are registered, this is my x variable, and so I'm just going to plug that in for x. Now again, I need to be careful because x was the number of boats registered in thousands. So I'm not going to plug in 716,000. I'm going to plug in 716. So y hat is going to equal negative 41.43 plus 0.125 times 716. And that gives me 48.07. manatees. I would not round this, okay? We're not talking about an actual number of manatees. We're talking about what our regression line predicts. So 48.07 is fine. Okay. That was the first method for finding the equation of the least squares regression line. The second method is done using summary statistics, and it involves a little bit of math. So there is a relationship between correlation and slope of a least squares regression line, and this is it. The slope of the regression line is equal to the correlation times the standard deviation of the y variables over the standard deviation of the x variables. This equation is on the front page of your reference sheets, so you do not need to memorize it. You need to know where to find it, though. Also, the least squares regression line always passes through the point x bar comma y bar, meaning the average x value and the average y value. So the least squares regression line will always simultaneously pass through the average x and the average y. We can use these two properties to go from summary statistics to least squares regression lines. Let's try an example. So I'm given the correlation, the standard deviations of y and x, and the averages of y and x. And so I'm going to start with that slope equation. B is equal to r times sy over sx. And so r is negative 0.62, sy is 2.7, over sx is 10.2. And that gives me a slope of negative 0.164. This should make sense. The sign of the correlation, negative, should match the sign of the slope, negative. Now, I'm going to take my general equation for the least squares regression line, y hat is equal to a plus bx. And I know b now, so I'm going to substitute that in. Y hat is equal to a plus negative 0.164x. This is almost the equation of least squares regression line, except that I still have this a there that I need to solve for. The way I'm going to do that is to plug in x bar and y bar for x and y and solve for a. So for y hat, I'm going to plug in the average y, which is 2.8, is equal to a plus negative 0.164 times, for x, I'm going to plug in x bar, 12. And I'm going to multiply these two together and move them over to the other side. And when I do that, I get a is equal to 4.768. Make sure you and your neighbors both got that. Okay, so that leaves me with y hat is equal to a, 4.768, plus b, negative 0.164x, okay? Or I could have written it as y hat is equal to 4.768 minus 0.164x. Those are the same, right? Okay, here's another example. I want you to solve this one, so please pause the video and solve. Okay, when I do this one, I start with the slope. B is equal to r times sy over sx. Here r is 0.95, sy is 12.8, over sx is 8.15. And when I do that, I get a slope of 1.492. Okay. Now y hat is equal to a plus bx, but I know b, so this becomes y hat is equal to a plus 1.492x. And all I need to do now is solve for a, but that's easy because I know x bar and y bar are going to fit in for x and y. So I'm writing 15 is equal to a plus 1.492 times 10. And I multiply these two together, subtract them to the other side, and I get a is equal to 0.08. Is that what you get? So my final answer is y hat is equal to 0.08 plus 1.492x. And that is my answer. So that's the second method. The first method is given the data, you find the equation of the least squares regression line in the calculator. The second is given the summary statistics, you do algebra. The third method is using a computer output. So there should be a handout that's going to get passed out for you to keep. Please hang on to this. So pause the video and get the handout passed out. And here is what you are all looking at. This is the output from a linear regression software, and it gives you the equation of the least squares regression line. It also gives you a lot of other stuff. Okay, it gives you a lot of stuff you're not going to use. For the equation of the least squares regression line, you are only going to be looking at this coefficient column. That has everything you need. I have the word constant here, so I have the constant coefficient, which in this example is 1136. And then I have a word here. In this case, it's seats. That word will not always be seats. That word tells you what your explanatory variable is. And then I have the coefficient here. So the coefficient of the explanatory variable, well, that's the coefficient of x, which is just the slope. So the constant coefficient is the y-intercept, and the coefficient of the x variable is the slope. And that's it. Y hat is equal to A is the y-intercept, 1136, plus B is the slope, 14.673x. This is the easiest one, but it's the one that people struggle with for some reason. For now, you will not use any of this stuff. None of it. This is r squared. We haven't really learned what r squared means yet, but from that you could get the correlation. So right now it's a percentage, so you would rewrite it as a decimal, 0.57, and take the square root to get r. And you know that that could be positive or negative, so you would just make the sign match the slope. So the square root of 0.57, whatever that is the correlation, and I know it's going to be positive because the slope is positive. We'll talk about that more a little bit later. Here's another example. I want you to write the equation of the least squares regression line. Pause the video for just a second. Okay, this really should have taken you 10 seconds. I get y hat is equal to A, the y-intercept, which is 7.764, plus B, the slope, which is 0.76941 times x. A, and this is B. Okay? And that's it for today's lesson. Okay, homework number 2 is up here on the slide, and as of right now you have a quiz on Monday that is going to cover Thursday's lesson as well as video 4 and Friday's lesson. So it's going to cover direction, form, and strength, it's going to cover the meaning of correlation, it's going to cover making scatter plots, and it's going to cover what we did today, finding the equation of the least squares regression line. Okay? Have a good day, guys.